September the 5th, 2025. Guys, I've got this paused, and these are some of the latest images coming in from our sun from the Solar Dynamics Observatory. It is 6:33 p.m. and this is kind of in the middle of the images. I've got it paused here because we've got a kind of an abnormal flare, and it's coming from this area, and you can see the coronal mass ejection here. I'm going to play it through, but again, this is unusual, and it is directly Earth-facing, and they are tracking a CME, and because these can be very dangerous because they're so long, and we've seen them spiral out, and the timing on them is usually pretty good. And I remember the last one that was this large that we tracked. It came not from this section of the sun, but just up to the left, and it was predicted to. And we looked at the timing and changed it over to from UTC time to Hawaii time, or excuse me, to Alaskan time, and it was expected to hit at 5 p.m. that morning. It was very powerful too, strong. It woke a lot of people up. But one of the watchers here, and when it came in the comment, one of the subscribers, I can't remember your name, it's been a few years, but you said, BP, I set my clock at 5 a.m. that morning to wake me up to see if you were correct about this thing hitting the planet and where it would hit, because a lot of times, if they leave the northern hemisphere of the sun, they kind of hit the northern hemisphere of the planet. This one's leaving the center, but it looks like it is more southerly directed, but that can fool you when you're looking ahead on images. Anyway, he said, I set my clock. He said, the clock went off and the house shook at the same time. Now, that wasn't my timing, but that's how accurate it can be, and it was a strong quake. If you're still a subscriber after all these years, come in and make a comment if you remember that. But I'm going to play it through. Then we're going to look at the CME tracking on this thing. The sun has been relatively quiet. We had a CME come in the other night. It was supposed to come in at 7. It hit at about 5. I was watching it. We didn't have we didn't have many strong quakes, but there were more 5s than usual. It wasn't anything big and powerful. This one may be a little different, but let me play it through. Again, it's going to go from the from the 4th to the 5th today. And here it will start yesterday right there. You see a couple of those up in the northern hemisphere. See that? It's becoming very active. There's a different one, much larger. Check that out. We'll let it play all the way through. And I want to change the actual camera. And what this does is illustrate a really large coronal opening in the sun right here. You see that? What that means, especially in the southern hemisphere, is a lot of that is striking the Earth, and it increases the solar wind speed. It increases things like heart arrhythmias, all of that, guys. We've done a lot of videos on it, and this is a pretty large area considering if you put a planet the size of Earth beside the sun here, scale, I think I counted 109 just to cover one face of it right here, 109 of our planets. So that's quite large. And what we've got is, again, in the center, you can see the incoming possible flares. But in one coronal mass ejection, we know for sure, and a lot of solar wind stream. Now, this would be coming at us and slightly south of our planet because it's angled down. It's a curved area, just like a basketball. And so whatever angle it's pointed out at, that's going to catch the largest blow. But you can see the sun is starting to act up. Now, I also saw the sun act up as Comet ISON approached. I'm not sure if that has anything to do with it or not. And by the way, I did a little more research on Atlas and what it may be. And there was a little bit of trickery in some of the images that went out on mainstream media, and I'll show you those. But let's get through this. I want to show you this CME tracker. If I have time tonight, we will look at the Atlas observations that I did. Hold on. Guys, there's a couple things on spaceweather.com. It's been on our website at bpearthwatch.com forever. Scroll down on the links on the left, you'll see it there. But spaceweather.com is what we're looking at. First thing they're talking about, we got a total lunar eclipse this weekend for more than an hour on September the 7th. That would be Sunday. The full moon will pass through Earth's shadow, turning the lunar disk blood red. It's a total lunar eclipse, but no one in the Americas will be able to see it, but you guys and a lot of other places can. The zone of visibility includes Asia, Australia, Africa, and most of Europe. So we're going to get a lot of good images and probably some live satellite feeds. Maximum eclipse occurs at 1811 UTC, and they got a place where you can submit your photos right here to Space Weather. If you get any, do that. Let us know in the comments, and we can go there, and if you, with your permission, we'll put them in a video. I've got a couple there on Atlas itself. And in this section, it's called a sigmoid eruption on the sun. That's what you just looked at. They're giving you a detail, not of the explosion, but the pre-explosion, and the explanation is very good. It says, when you see an S on the sun, it usually means something is about to explode. You see that S curve right there? On September 4th, which was yesterday, NASA Solar Dynamics Observatory recorded a textbook sigmoid eruption, and that's what you're seeing. And if we scroll this down, they go into a little detail here. It says, researchers have long known that a sigmoid structures are structure in the sun's atmosphere herald strong explosions. Their magnetic field lines are twisted like a slinky. When enough tension builds up, they untwist explosively. It says this sigmoid hurled a dark plume of plasma more than 700,000 kilometers long into space. The plume is dark because the plasma inside is relatively cool and dense. That's compared to the background of how hot the sun is. These two qualities, that tightening and that coiling and then that density. See how dark it is? It's blocking out the sun and causing a shadow there, basically. Those are the two qualities that make a very potent CME. The explosion hurled a CME directly toward Earth. NOAA and NASA models agree that it will reach our planet on September the 7th. The impact could spark a G1 to G2 class geomagnetic storm with high latitude auroras visible during the lunar eclipse. Now, for you guys in Asia and Europe, the other places other than here, you're going to have not only beautiful auroras, but a total solar eclipse, guys. And so the auroras are going to be very bright. Please get some very good images and some films. Thank you. We wish we could see it here. Now, this is the model that they're tracking it with. Notice the time, 6, that's tomorrow on the 6th, 12, and that is UTC time. Come back 6 hours, and you're going to be looking at between 5 and 6 p.m. tomorrow afternoon on the East Coast, okay? Now, the reason I'm stopped it right there before it got to Earth is because they estimate this, but remember this was, again, they called it coiled up, and that S like a very tight coil. And the spring, when it unfolded out, it had a lot of speed involved with it. But again, tomorrow afternoon, probably by this time, it's 6:52 p.m. Central now, this thing will have already started to increase our solar wind speed. The density will increase somewhat, the impact point, but all we can do is watch it. But sometimes these can be more dangerous than like your radial burst, where you see a complete. Now, this is a link on Space Weather, and it gives you a lot of information. The temperature of the solar wind speed in kilometers per second, and solar density. And what we're seeing right now, guys, right here, where you see, and the purple indicates the solar wind speed. And normally it's around 320, and it was slightly elevated. And right here is where the impact of the CME we talked about a couple of days ago came up and put us just around in the, let's say, 647 kilometers per second. Guys, that is very, very fast. You're around 1 million miles per hour. Now, that came in, we didn't see any large quakes, but we saw some strong, smaller ones. And then it's back down now, into the, let's see what we're at, 440. Again, that's about 100 kilometers per second, or 120 above normal at 320. And but there's pressure there, and that's important. All of this is going to change as we start to see the solar wind speed increase tomorrow. Let me pull this up a little closer. But before, let me show you one other thing before I do. Up here, this is the magnetics involved with the solar wind, and anything coming in, a CME or whatever. And when they're separated, like right here, you see a purple zone, that's when the shields are open. And this is when they're closed. Everything's on the top of the line. They're very close. We don't have a lot of radiation getting in. But then when you get these bursts, you see how it opened the shield and a lot of radiation came in there. Follow me because I'm going somewhere with this. It affects everything. It affects radio signals. It affects astronauts. It affects flyers on aircraft. It affects you on the ground. And we're seeing it kind of bounce back and forth right now. And I'm going to pull it up to this very hour. And you can see that it is open. You see that? And that is from this solar wind speed, which is starting to drop right there. Again, we are at 429 right in there. But that's going to increase. And depending on and we've got a different angle of this coming in. So that could really force this open a little further. But when you see the red and black open this far apart, you'll see the purple gaps in those times, and that is when the shields are open, and we start to see radiation penetrate all the way to the surface of the Earth, and it scatters into cosmic rays. And I'm going to stay on space weather. Again, it's on our website, spaceweather.com. And they do a lot of work there with students out of California. And what you're looking at, and you can scroll to the bottom of spaceweather.com, you'll find this very close to the bottom. It stays there quite a bit because it's important. It is called stratospheric radiation. This is from March 2015 until last November, which has been, 9 months or 10 months now? Anyway, you see this balloon here, and what they do is launch balloons up. The students do, and then they get the stratospheric radiation readings from the monitor launched on there. And they also send up different really cool things on the balloon and all. Then they sell those like Star Trek memorabilia or whatever, and that helps support them, buy the balloons and everything else. But they get this information, and it's very important. And it's located right here on the California-Nevada line, up in the mountains. And again, this puts us into solar cycle 25. Now notice that the stratospheric radiation since 2015 started back here in solar cycle 25. We saw it very active, but it has dropped. Now why would that be dropping when we've seen some pretty large solar storms and things like that? It's because the faster the solar wind speed hits our planet, this radiation is thinned out. Just like if you sitting at a campfire and there's no wind and smoke going straight up, it's very thick, right? You can't hardly breathe if you get in it, but you get a little bit of wind, and then that smoke is going to blow to one side and thin out. And so it's pushed around our shields instead of just pounding it. And of course, these balloons are well within our shield, being over the mountains in California. They're still so far up that it's obvious that we have a very curved Earth, by the way. And let me just stop right here. I want to back up and show you what they're doing. And if you ever get somebody that's dead set on the Earth is flat, get them to watch some of these videos here. Again, space weather, and this is on the real-time space weather photo gallery. It's right below it. But what they've got now, and it's different things. Sometimes it's jewelry and things like that. But anyway, what they're doing is promoting the cost of the balloon flights. But notice the curvature of the Earth, and it's obvious, guys. Anyway, this week they've got Leonard Nimoy's Mr. Spock coffee cup. And again, they launch one up in space, and then I don't know if it's just that one that you see in the camera or not, but anyway, it supports the students there, and they are actually, and the professor there, I think, is running this website But it says, and of course they're not cheap, but it's a good cause. It says you can have it for $99.95. Either way, the students are selling the cups to support their Cosmic Ray ballooning program. Each one comes with a greeting card showing the heavy-duty ceramic cup in flight and telling the story of its journey to the stratosphere and back again. Anyway, that's a shout out to Space Weather because we use them so much. But again, beautiful images of our planet. Look at that. Now let's go back down, and here's where the information becomes very important that they're gathering and other people are gathering. Now, you would think this was good news, but when this happens, there's other things that do happen during that period of time. And this talks about that also, but just scroll right down below there. Let me get it right here. It's saying what's going on. Ironically, the radiation drop is caused by increasing solar activity. Solar cycle 25, which we're in now, has roared to life faster than forecasters expected. The sun strengthening and its increasingly tangled magnetic field. You just saw a very tangled magnetic field release. It repels cosmic rays from deep space. In addition, solar coronal mass ejections, or CME, sweep aside cosmic rays, causing sharp reductions called the Forbush decreases. The two effects blend together to bring daily radiation levels down. So you've got positive and negative effects. Who cares, it says. Cosmic rays are surprisingly down to earth in the form of space weather. They can alter the chemistry of the atmosphere. Think about that. Triggering lightning and penetrate commercial airplanes. According to a study from the Harvard T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. So do frequent flyers. And think about the astronauts. The researchers listed cosmic rays, irregular sleep habits, and chemical contaminants as a leading risk factor. A number of controversial studies listed here, 1, 2, 3, and 4, you can come here and click on, go even further, linking cosmic rays with cardiac arrhythmias, and sudden cardiac death. They would never, you have a heart attack, you hit the ground, the autopsy says heart attack. Just the same way they would do if you had an aortic aneurysm like I do, and I wouldn't have discovered it if we didn't go through all the tests. Because if you do a regular heart test, it will show that you're all good. Because they'll do the stress test, all of those tests, chemical tests, all of that, all the sonograms, the CAT scans, and all of that. But unless they do what they call an echo, then what they're not seeing with just a heart test, even with the dye, is the damage outside the heart. And people will die when an aortic, especially an ascending aortic aneurysm, which I have between my heart and my brain. If it goes, the same thing happens. They claim it was a heart attack when they never tested for that. So if you have heart problems and you've had this, I didn't mean to go here, but I've just been through it, and you go through a lot of heart doctors, they know you're in pain, say all the symptoms are there as far as your left arm hurting, the pain and all of that, but they say, but all your tests on your heart look good, and you walk out. Well, if they did not do what's called an echo, where it's just like a sonogram if a lady's pregnant, they put the paste on your chest there and the little monitor, it's painless, right? There's no sedative or anything else. And then on the screen there, you see what your heart's doing, and they found that one and 2 in my neck, smaller. Anyway, so if you're having heart problems and you've had the frustration, and they're saying, look, your heart beats fine, the valves look good, and I'm telling you from experience, we don't see any problems, and you walk out and die. Make them do an echo, even with the minor symptoms showing up, because if you can stop it at a certain point, they can possibly help it. And there's medicines out there which I hate to take, but they will allow it to handle it a little better, just saying it like that. But it says The radiation sensors, it's a technical note, on the board, the helium balloons detect X-ray and gamma rays in the energy range 10 kiloelectron volts to 20 or 10 keV to 20 MV. These energies span the range of medical X-ray machines, that's my point, and airport security scanners. That's why when you're doing medical X-rays, they're behind a barrier. Okay? That's another good thing about the Echo. There's no X-rays involved in that, but they're going to milk your insurance for every test in the world but that one, if you let them. And so I think it's going to extend my life by a few years by knowing that and taking the proper precautions. Anyway, again, it says a number of controversial studies, 1, 2, 3, and 4 listed right there, go even further, linking cosmic rays to these arrhythmias and sudden cardiac death. If you're anywhere in an age where you may think you may have a heart problem or were born with some trait or whatever, then you need to have an echo. Just listen, because that and understanding another one, write this down, and most heart doctors are not aware of this. It's called cervical, let me think for a moment. Oh yeah, cervical angina. A lot of them will look at you glassy-eyed when you explain that. And what that is, guys, if you've been in an accident or something like that and you damage your neck really severely, like I said, I've got 2 aneurysms there, but it can actually create a curve in your neck, in the bones in your neck that push on the back of your skull, and that can mimic all the signs of a heart attack and can kill you just like a heart attack. So even if they say even your echo looks good, then you need, before you go to a heart doctor, call them. There's not a lot of them, and especially the nurses that do the test, they have no clue. And there's clinics in Florida and other places that do just this type of work. But again, cervical angina, damaging your neck. You know, you've got a nerve. I think that's where they tap in with the pacemakers and all that goes from your brain down to tell your heart to beat. That can be damaged with neck damage. And that is what they found with me. I'm not trying to say anything other than maybe save some lives. Again, check, you want an echo, and you want to find a doctor that can deal with cervical angina. That means it's your heart, and the problems are caused by your neck. Anyway, I hope you got something out of this, guys. We're watching it. You watch it if I have time. If not, I'll do it first thing in the morning, show you some of the new stuff that I found on Atlas. It's a heads up. Be safe.